Hey everyone, just another update on the Spectrum game creation tool. This is quite a major change in the way that things were working before. I've revamped and rethought a lot about how objects work in terms of rooms and rooms themselves in general. So the rooms editor looks very different now. Um, I'll go through some of the changes. So basically you've got this here, which is your list of rooms. Currently there's only one, the start room. This was always there before, so there was always the concept of multiple rooms. This new list here is the list of object. They're actually object references or object instances in this current room. So you can see we've got two bubbles and an enemy. An instance is a use of one of the objects from the objects list in a room. So it shares the logic. So if we go to the object logic, it shares the logic. Each instance shares the same logic, but it has its own instance of the variables. So each one can have its own value for top, bottom, YD and DAR, which I'll go into in a moment. So each one of these will have their own, and I can demonstrate that as part of this demo. Down here, slight change. So before we had the map editing or the tile editing, so you had the list of tiles. It's just the one tile created at the moment, this one. But that's very similar. So for painting on the map with tiles, you still use that. This new thing down here is a display of the objects that have been defined. So we've got enemy one and bubble are the two objects. And from here you can drag and drop objects onto the scene. So you just drag and drop them and it'll show up as a new object. And you can move them around, and down here you've got some extra information. So this is the mouse position in pixel coordinates within the room. The green is the position of the object within the room, which is going to be slightly different because it's the origin of the object up here, not the mouse position. So it allows you to accurately place objects. So we place that one there. We have a new bubble. To keep this a little bit cleaner, I've moved things like changing names and other parameters away from this interface so it didn't get too cluttered. So now for editing properties of an object reference or the room itself, you double click and it brings up this dialog. So we can see in here we've got the position. Each object in a room has an initial position, which can be used. It has to be coded, but it can be used at the moment to place it initially as you enter the room. That has a name which you can edit, and then this is a list of the variables that show up in the object definition. So you can change the values of the variables for this instance of the object, this copy. At the moment both bubbles have the same top and bottom values, and you'll see how that matters in a minute. So if I go quickly to the logic for the bubble, it's a bit complicated, but I'll stress one more time here that this set of nodes that I've got here to work with are very early. I'll be combining a lot of these into much more complex, much more functional nodes, so you don't have to have quite so many. But to do the simple things for this testing, there's actually three trigger points here, two always and one initialize. So you can see the initialize is very simple. It just moves the objects to this is a new node, instance data, which is access to this value here, these values that are in the instance. That may change, but so you can get the X and Y of the object placed in the room and move the object there. This obviously would probably be automatically done, but for now that's what it does. And then moves on to set the variable YD, which is a current Y position rather than the initial Y position, to the value of the bottom variable, and then sets the direction to -1, so it's going up because -1 in Y is up. And then we've got this complex always trigger here, which is basically moving the Y position. So it's setting the variable Y to Y plus dir using a math node, and then it's checking to see if the YD is less than or equal to the top, and if it is, then change the direction, and if not, it's checking if it's hit the bottom and if it is, change the direction again. And then we've got a secondary always trigger, which will be put into the same function in the final C code, which I'll show you in a moment, which just basically moves the object to that position, the initial position in X, because we're not moving in X, and the calculated Y position. So that's the same. That same logic will be generated once for that object, and any use of that object will use that same code, but will have its own versions of these variables. So if this one here, this object here is currently at 56, so it's at the bottom, and the top is 12, which will be up here somewhere. So it should move up and down. They're both the same, so it should move up and down continuously between 56 and 12. So if I export this to just save it to that so we can see, we can have a quick look at that header file. So things that have changed, we've got a few changes in here. You can see here the struct now has all the different variables in here. This is a struct for the variables of a particular object, and they're assigned at the instance, which I'll show you in a second. There's a constructor function which just initializes various sprite based stuff, an initialize function which runs any triggers from the logic that are marked as initialized. So in this case we're moving the object to the reference X and Y, and then we're going to set YD to bottom, which was the same we saw. Go back, set the YD to the bottom here, and then sets the direction to -1, so it's going down, up, sorry. And then in the always, you can see now we've got these two routes through the graph from both trigger points. So there's the move, and then the rest of this is the logic for checking the top and bottom and changing the direction accordingly. So that's exactly as before. And then a little bit further down we've got the enemy stuff, which doesn't do anything at the moment because the enemy's dumb. And then you've got the objects are they're effectively the list of function calls for the initialize, always, and constructor for each object, but they don't any longer contain any data. The data is in the reference. We've got two object definitions, and then further down we've got the list of object data structures for the objects references or instances in each room. So they're named by the room and the object number, and that's the data. So you can see we've got 12 and 56, 12 and 56, which are the two bubbles that were that I showed you had the information set, and then we've got the enemy and the third bubble that I just added, which have no data set because we didn't get around to setting that. And then I have a list of room objects. So these are the references to the objects in the room. So it defines the object definition index, which is the one in here. So it looks up which object definition it is. It's got a pointer to the data, which is this here, this structure here that's been generated, and then it's got the static data, which is the X and Y position at the moment. I don't store the name, don't see any reason for it at the moment. So you can see the only one that's different here is the object definition on the enemy. The third object is 1, which is the enemy object definition. And then there's the actual room itself, which has got the map with the print statements, and there's no logic in here at the moment, but it's got 4 objects and a pointer to the list of objects, which is this. So with that all in place, if I quickly copy that back into my working folder and rebuild, it takes a moment now, and then go to the emulator, and hopefully if everything's worked according to plan, we load that up and the two bubbles should move in sync up and down. The other one does. It's going to drop off because the bottom and top were never set on there, so it's just going to go on forever. But you can see the important part is the top and bottom are being honoured here. So if I reset that and we just do another quick test, if I go back to the room and set bubble 1, for example, change its top value to 32, and then export again. So that should change the ceiling point of the second bubble, which will mean they'll move out of sync if everything works according to plan. And it shows that the data for each instance is isolated from the object itself. There. So that's the first instance, the first bubble, but it stops at 32 instead of going all the way up to 12, and you can see they're now running independently of one another. But the important thing is that they each have their own copy of the data, but the logic is shared. That's it for now.